So hello friends, in today's video we will discuss about the spontaneous emission. Spontaneous emission, which is the phenomena which happening in the EDFA, Erbium Dopped Fiber amplifier, or you can say the amplification process. This spontaneous emission process happens. So we will discuss in details about the spontaneous process in today's video, which is basically the part of the EDFA working, how the EDFA works. So we will discuss in details about that for working in principle in separate video, but here we will concentrate on the spontaneous emission. So let's see what is the spontaneous emission. So first of all, we just need to know the atomic orbital structure. You can see here, this is the atomic orbital structure. This is the nucleus. This Z1 is the electrons, and this is the N1, N2, N3, N4. These are the different energy state, and you can see this is the distance from the nucleus. So the energy of an electron orbiting an atom nucleus is larger for orbits further from the nucleus of an atom. However, quantum mechanical effects force electron to take on discrete position in orbitals. So this is the quantum mechanicals which forcefully the electrons to take on discrete position in the orbital. Basically, these thermal mechanical effects balance or force the electrons to travel in their system, or you can say they are in energy levels and move around the nucleus. So the electrons are found in specific energy level of an atom. So there are specific energy level of an atom, and the electrons lies in that energy levels. When an electron absorbs energy, either it is from light or for heat, it receives the incident quantum of energy. By transition are only, but the transition are only allowed between discrete energy levels, such as the two shown above. This leads to emission lines and absorption line. It means whenever the electron, suppose this electron N1 receives the energy either from light or heat, it can go either in N2 or N3 or N4. So these are the discrete energy level in which the electrons can move by absorbing the energy either is from light or from heat. You can see here these are the electrons which is orbiting the nucleus in the same way. So when an electron is excited from a lower to higher energy level, it is unlikely for it to stay that way forever. It means because we have already know that any system want to be in stable state. So whenever the electron absorb the energy, it moves to the higher energy. It just want to come to the lower energy, and in this process, this decay some another photons. So an electron is an excited state may decay to a lower energy state which is not occupied. It means whenever the electron is moving from ground state to any higher energy state, then when it moves back to the lower energy level, it will take place that is not occupied, means in the free state, free space. When such as an electron decay without external influence, emitting a photon, that is called the spontaneous emission. It means whenever the electrons absorb the energy, it moves to the higher energy level and it automatically comes to the lower energy level from the higher energy level. Then this process is called the spontaneous emission. It means the emission is not happened by any other means of force. When such as an electron decay with an external influence emitting a photon, that is called the stimulated emission. Means when the electrons move from higher energy state to the lower energy state by the influence of any other photon or the incoming light photons, then this emission is called the stimulated emissions. In stimulated emission, an incoming photon interacts with an excited atoms or molecule, causing it to transit to a lower energy state. And in this process, the incoming photon stimulate the emission of second photon that is in identical energy phase and direction to the original photon. So this is all about the stimulated emission. But the spontaneous emission happens automatically without any influence of an electrons or photons. So stimulated emission is the fundamental process behind laser where photons are amplified coherently. You can see here this is the energy level, this is the distance from nucleus, N1, N2, N3, N4. So you can see this is the ground state, this is the excited state. Even in the ground state, it is the excited state. And you can see this is the delta E, this is the energy difference. And delta E is equal to E2 minus E1, and that is equal to H nu 0. H is the Planck's constant and this is the linear frequency. So you can see before emission, there is a electron you can see in the excited state. During emission, what happens? During emission, it just release an spontaneous photons. Sorry, it during emission, you can say this is the spontaneous emission. So during spontaneous emission, it just release an photon which is in random in the direction. This is not equal in the phase of the incident photons. So this is process called the spontaneous emission, and this is the main cause of noise because what happens, this signal is not in the phase or in the same energy of the incident photon. So what happens, this you can say the unwanted photons which is not helping to amplification the incident photon, that's why it is called the noise. And when this you can say this spontaneous emission happens in the gain medium, then this is stimulated, this is created as a large number, or you can say that at the large level, and thus is the main cause of the amplified spontaneous emission. We will discuss ASC in different videos. This is you can say this is the stimulated emission because what happens, the excited state electrons is interact with the incident photon and release the same frequency, you can say the same frequency and phase another photons. So this stimulated emission helps in amplification, but this spontaneous emission does not help in amplification, but this is against the amplification. This will create the noise. You can see here, this is the photons stimulated, sorry, spontaneous emission. If an atom is in excited state, it may spontaneously decay into a lower energy level after some time, releasing energy in the form of photon, which is emitted in the random direction. And this process is called the spontaneous emission. You can see here, the spontaneous emission take place without interaction with other photons, and the direction and phase are random. This is not any specific direction or phases. These are random. If a light source, you can say if a light source, the atom is in excited state with energy E2, it may be spontaneously decay to a lower energy level with energy E1, releasing the difference in energy between two states, as the photon will have angular frequency omega and energy HW. It means it is want to say when the spontaneous emission happen from the E2 to E1, so a photon is generated which this photon has an energy equal to E2 minus E1. You can say E2 minus E1 is equal to h nu, whereas the Planck's constant, noted h nu is equal to h v naught, whereas the h is the Planck's constant and v naught is the linear frequencies. The phase of the atom in the spontaneous emission is random, as in the direction which the photon propagates. You can see this is the propagation direction of the propagation of incident photon, and this is the direction of the photons which is generated by spontaneous emission. So you can see these both are different. So this photon does not helps in amplification, but in noise, generate the noise. This is not true for the stimulated emission. An energy level diagram illustrating the process of spontaneous emission you can see in the below process. So this is all about the spontaneous emission. Thanks for watching.